Okay, this is going on page 89 when we're done. And we're going to look at reference angles. Part of this is a review. We've already talked about reference angles. That was before Christmas, though, so we're going to talk again. And I will just tell you right now, reference angles are super easy. If they're difficult to you, you're making them way harder than they need to be. I'm in a different spot with pre-AP, and so we had done all this. I gave them a test before Christmas. It was a disaster. The kinds of answers I got for reference angles is what bothered me. Not that you get them wrong. People get stuff wrong all the time. It's whatever. It's the kinds of wrong answers I got, which was clear that we had no clue what the heck was going on. So we've got to make sure, we've already talked about reference angles together in here. So we're going to do this again. Make sure you understand what they are, because that, along with which quadrant I'm in, like all these pieces are going to come together for us to get some information out. So we've got to be able to make sense of them. All right, so my reference angles. It says for an angle theta in standard form, the reference angle, and here are the key words here, positive acute angle, and it's formed by the terminal side and the x-axis. Always the x-axis. I don't care about the y-axis. It's positive, it's acute, it's made with the x-axis. So it says sketch each angle, then find the reference angle. All right, so we're going to sketch this 120-degree angle. What quadrant is that angle in? Second quadrant. We all agree with that, right? So I'm going to start here. I go to, this is 90, so then how much farther do I go? 30. So I go 30 degrees more, so it's about a third of the way. So 120 is this angle right here. So I have graphed the 120. I need the reference angle. It is made both the terminal side and the x-axis. So this is my reference angle right here. What is the measure of the reference angle? 60 degrees. That's it. Okay, everybody okay with that? Right, what do you mean by, I'm not sure what you mean. Like saying that it's a reference angle? No, in this case, instead all it said was find the reference angle, just writing it that it's 60 like that is fine. We're going to, it's going to be in a list of things we find in just a minute, so usually I just put an R with like a little colon to say, hey, this is the reference angle. That's a good question. All right, so 330, what quadrant would that be in? Fourth quadrant. So I start here. If I go all the way around, that's 360, but I don't make it that far. I have to back up how much? 30. Here. So this is my 330-degree angle. My reference angle would be what? 30 degrees. And it doesn't matter if you have to go clockwise or counterclockwise to get back to the x-axis. It is positive, always. It's always positive, always acute. So negative 225. Since it's negative, when I start at 0, I go in which direction? Clockwise. And then which quadrant will I end up in? Second. So if I go from here to here, this is 180, right, to get to back to the x-axis. Then I would have to go how much farther? 45. So that's about halfway, or it is halfway. So this is my negative 225. And then my reference angle would be what? It's always acute, always created with the... How much farther did I go from 180? 45, right? And so if you ask yourself that question when you're graphing it, like, okay, I made it to 180, how much farther do I go? 45. Well, then it's 45 degrees to get back. Does that make sense? It is what it is. Yes. Yeah, that's a good question. If your angle is in the first quadrant, then the angle and the reference angle are the same thing. Like it's its own reference angle. That's a good question. Everybody okay with that? What? Oh, well, yeah. But what he's saying, like if the angle was 60 degrees, then it would be right here, and then my reference angle would be 60. Okay. Oh, I see what you're saying. Okay. Okay. So if it was negative 330 instead of 330, then yes, it would be up here. So the angle is, so yes, if it's a negative angle in the first quadrant, then your angle just comes to right here. It would still just be 30 degrees. So a negative 330 would get me to here, and then I'd have 30 degrees more to go. Yes. When you asked me that question, I was thinking like you were asking like, what if the angle itself is 30 or 45 or 60? Then, oh, that is what you were saying. Okay. But then we were clarifying it differently. Okay. Does that make sense though? Good question. Anything else? Those are good questions because those things can happen. All right, so we're not really going to do much more stuff with degrees. All right, we're not even going to work some more of the degree problems. We need to be thinking in terms of radians. If you follow along with me, radians are easier anyway. And you have to be able to think fractionally, but don't let that freak you out because it's not crazy fractionally. When we first did this, I told you it's okay if you need to convert to figure it out and then convert back. We need to not have to do that anymore. So this 5 pi sixth, when I go to graph that, okay, I'm going to start here. I want to think in terms of sixths, right? For radians, this is 0. What is this in radians? Pi, and then this is 2 pi, right? So if this is pi, that's like 6 pi over 6, right? So I don't quite make it to 6 pi over 6. I have to back up to get to 5 pi over 6, which means then that my reference angle is pi sixths. You see how easy that is? And trust me, radians are easier than degrees. There were some of you on Wednesday, you got all your radians down that unit circle beautifully, and you were like, I don't know how the heck to do the degrees. Because with the degrees, you have to add and subtract, and the numbers change. With the radians, because there's fractions, you have pieces. You know, how many sixths do I have? How many thirds? Whatever. All right, so 7 pi thirds. Well, if I'm here, if I go around, this right here gives me 3 pi thirds, right? Then this would give me 6 pi thirds, because that's 2 pi. And then I got to go one more to get to 7 pi thirds. So my angle looks like this. And then my reference angle would be what? Pi thirds. Because remember, to get here, that was 6 pi thirds, and then I had to go one more. It's pi thirds. Okay. So then for number 6, I start here. It's negative, so I'm going clockwise. So this is 4 pi fourths. All the way around is 8 pi fourths, but I don't make it. So I back up 1. This gives me my negative 7 pi fourths. So then what's my reference angle? Pi fourths. Now, I could ask you a reference angle for any angle. Like, what's the reference angle for 170? 10, right? It would take 10 degrees to get there. So I could ask you for anything, but mostly right now, we are just working with the special angles that are in our unit circle. So if we're working with our special angles and we're in radians, you only have 3 choices if I ask you for a reference angle. It's pi sixths, pi fourths, pi thirds. That's it. And with the radians, the denominator totally gives it away, right? What is the reference angle for 29 pi over 6? Pi sixths, right? 1,387 pi thirds. Pi thirds, right? Now, I'd have to figure out how many rotations that is to figure out what quadrant I end up in, but the reference angle itself is going to be whatever that denominator is. It is that easy. Don't make it harder than it is, because this is a huge part of what we're about to do. Well, if it asks you, like, you need to be able to. There will be times where we need to graph it. And if all I care about is the reference angle, then no, I don't have to be able to graph it. But I'm usually concerned with what quadrant I'm in too, which means I do need to so you're not going to be asked for 1,872 pi over 3. I mean, that's a lot of rotations, right? But you have to figure out what quadrant you're going to land in. But regardless of what quadrant you land in, if it's a third, it's pi thirds. That's your reference angle every time. Okay? Easy enough? It's really not that bad. All right, let's jump down here. And we're going to do 9 and 10, because like I said, we're not even going to talk well, maybe we should, because we're going to do more of these than what we get to today. Now, let's just go ahead and do 9 and 10. I don't want to even talk about degrees anymore. The directions say, use the reference angles and the trigonometric function values for angles in the special right triangles to find each trigonometric value. All right. That's a lot of words that you don't know what they mean anyway, but we're not really going to do it that way because we've already talked about the unit circle. This way actually makes it harder. So don't even worry about what it says because it probably doesn't make sense anyway, and that's okay. But we're going to find these values, which are similar to what I was asking you out there, except I didn't ask you about tangent and cosecant. I was only asking you about sine and cosine and in the first quadrant. And if you can get sine and cosine in the first quadrant, you can do all of these, all right? But you have to know what quadrant you land in and what the sign, the SIGN, is going to be. So remember all students take calculus, right? Okay, So this means that in quadrant 1, everything's positive. In quadrant 2, it's only sine, and what's its reciprocal? Cosecant. In quadrant 3, it's only tangent, and its reciprocal, which is cotangent. Quadrant 4, the only thing that's positive is cosine and secant. Okay, secant. All right, we're good? So as we go through these, we're going to have to find specific things. Every single time, you're going to ask yourself the same questions. I do this too. This is what I want to make sure that you understand. I'm not saying you have to write this down because I have to see all of your work. I'm telling you, if I'm going to give you answers to these, I'm doing the exact same thing myself, and I understand this way better than you do. All right? Now, do I always write it all down? Most of the time, because if I don't, I'll forget what I just thought, and I'll have to go think it again, and that's never good. So it's not going to, there's certain things you just jot down so you can get to where you need to be. So the first thing is, if it's not sine or cosine exactly, which it's not, it's tangent, you write it in the form of sine or cosine. So tangent is what over what? Is it sine over cosine or cosine over sine? Sine over cosine. Okay. So then just so that I know what's going on here, I'm going to write this is the sine of theta over the cosine of theta. Then I have to ask myself, this 11 pi over 6, what quadrant do I end up in? Okay? So just think about it for a second, see if you know, or see if you can even think about how you're supposed to know. What do you, anybody? Fourth. Because you want to think in sixths, right? If to get around to 2 pi, isn't that 12 pi over 6? So if I back up 1, I'm in the 4th quadrant, right? Okay, so I'm in quadrant 4, so I'm going to write that down, or I'll forget which quadrant I just thought of. The reason the quadrant matters is because that's going to tell me whether my final answer is positive or negative. And in quadrant 4, is tangent positive or negative? Negative, because what's the only thing that's positive? Cosine. Tangent is positive in quadrants 3 and 1. So in quadrant 4, tangent is negative. Does that make sense to you? That's why you care about the quadrant. Okay? And then we need the reference angle. What's the reference angle? Pi 6. Okay. All right, everybody with me so far? If you can come up with all that stuff, we're golden from here. And this may seem like a lot to think through, but the more you do it, the better you get. And we got to get really good at this. So what I want to do here then is I need to do sine divided by cosine. Now, I could make it one giant ugly fraction, but doesn't this mean division? So since I already know I'll have a fraction and a fraction, I'm going to write it down as like elementary school division. It just makes it easier. So I need the sine of theta and the cosine of theta using my reference angle. Because if I use this to get these values, I know what the sine is in the end. It's going to be negative no matter what happens. Negative, whatever happens, right? So pi 6, that's your ring finger. In the numerator, you get the sine of theta. Okay, sine of theta is what? 1/2. So it's going to be 1/2 divided by, and we're going to write divided by how we almost never write it, just because it makes it a little easier on here. The cosine of theta, which is what? Square root of 3 over 2. Okay, and then I just got to use very basic fraction rules. When I divide fractions, I multiply by the reciprocal, right? So it's going to be negative 1/2 times 2 over the square root of 3. And then what happens to the 2's? They cancel out. So that's going to leave me with negative 1 over the square root of 3. I'm not even going to write that yet, because is that legal to leave it like that? No. So I'd have to rationalize. Hopefully you can rationalize like as you write it, right? So we get negative square root of 3 over 3. And in the end, just double check your positive and negative so you make sure you didn't lose it somewhere. Or sometimes I forget to write it at the beginning of this process, or I just don't. And I do my thing and get the number and then just stick the sign on at the end. That's fine too. You just want to make sure. So are you good with that? Sine and cosine, you got to know them for your reference angles. Tangent, we will get to a point where you will know them. We'll look at some of the patterns. But right now, we should just be able to find them. Most of what we're doing is not going to be this involved. Okay? Some of it, it's just going to give you an answer and we're going to move on. And we'll look at those too. Okay? So let's look at cosecant. Cosecant is not sine or cosine. So what is cosecant the reciprocal of? Cosecant is the reciprocal of sine. So this is 1 over the sine of theta. Negative 2 pi thirds is in which quadrant? It's the, what? Oh. Okay, that's fine. I'll take it. Thank you so much. Yeah. Oh, got it. Thank you. Negative 2 pi thirds is in which quadrant? Third. Good. Because remember, if I'm here, and if I go here, that's negative 3 pi thirds, so I got to back up one. So I'm in quadrant 3. So it's not a bad idea to have like an x and y axis, so you can maybe just do this, even if you're not drawing on it, just to kind of think how you're rotating. So in the third quadrant, is sign positive or negative? Negative, because the only thing that's positive is tangent, right? So it's negative. And then what would your reference angle be? Pi thirds. Okay. So pi thirds is which finger? Your index finger, right? So this is pi thirds. I need the sign of pi thirds. What's the sign of pi thirds? Square root of 3 over 2. But that's not really what I write down, right? I could put 1 over that, but doesn't this just mean the reciprocal? So instead of the square root of 3 over 2, I'm going to write 2 over the square root of 3, because it's the reciprocal, right? And then I have to rationalize, so that's going to give me 2 square root of 3 over 3. And is it positive or negative? Negative. And this is your answer. I realize that right now you don't know why you care and why we need this, but I can't talk about why we care and why we need this until we know how to find it, right? We got to get good at finding these things, then we'll figure out why it's even important, okay? I promise you it's important, though. It's not just so we can get it done. I promise. I wouldn't be spending time on it if it wasn't that important. All right, are we good? Okay, because this is going to take some practice. It'll get better and better and easier, I promise, just like everything else, but you got to practice it for that to happen. Okay. Let's talk about quadrantal angles, and then I think we might stop for today, and then do some more of this on Monday. But on Monday, I'm going to give you a quiz. Your quiz on Monday is going to be very similar to the yellow paper you filled out when you came in. Okay? Basically, the hand trick, first quadrant, sine and cosine. That's it. You got to know those. Okay? And you got to be able to know them fairly quickly so we can get to understanding the rest of this stuff. Okay? All right. So quadrantal angles. If you have an angle that lands on an axis, it's not in a quadrant. So we answer it differently. And this part, I believe, is a review, too. I think we've already done this, but we need to talk about it again. So when the terminal side of an angle, theta, that's in standard position, lies on the x and y axis, it's called quadrantal. So here, this is either 0 or 2 pi, maybe. So if I said, what quadrant is that in? Well, it's not. So the answer is quadrantal. And you have to write it out. I promise your hand won't fall off. And it's quadrantal, and it's on the positive x-axis. So what's important for us, the reason we care about the quadrants on the other ones is to know if our answer is positive or negative. The positive or negative part takes care of itself with the quadrantal angles. So what's important for us then here on these is what the ordered pair is. So the little point that rotates around, when it's here, what's this ordered pair? No. 1, 0. Okay. So then this one, if I end up and it's pi halves, it's quadrantal. So yes, I'm going to make you write it 4 times because you need to know that you have to answer it that way. And this is on the positive y-axis. But what helps us with the part that we're doing now is the ordered pair. So what's the ordered pair at pi halves? 0, 1. So then when I'm at 180 or at pi, again, it is quadrantal. And this is on the negative x-axis. What would that ordered pair be? Good, negative 1, 0. And then quadrantal. This is the negative y-axis. And this ordered pair would be 0, negative 1. Okay. Everybody okay with all that? All right, so the back of this we're going to do on Monday. We're going to quiz, and then we're going to do the back of this. I'm going to give you the assignment now, though, because you need to get started on it. And then I will, oh, if I can find them. You know what? I think I recycled them. Oh, dang. Ooh. All right, hang on.